Welcome to lunch, everyone. We hope you had a great morning with the technical sessions. We're excited to offer something that is new to Moab.Con, which is presentations from press and industry analysts. And we're very excited to have Chris Willard from Intersect360 Research, which is the leading HPC-focused analyst firm. We've known Chris for a long time. He does a great job. He and his partners at Intersect360 do a lot of research, especially with user communities like this one. And he's going to talk to us today about HPC trends. So let's hear a hand for Chris Willard.
Well, thank you very much. Let me just start off with a quick overview of Intersect360. We are a market research firm. We do the standard stuff, market sizing, forecast, and technology trend analysis. I think what makes us unique is much of our data comes from end user surveys. Some of you might have seen requests for our surveys coming through HPC Wire, and some of you may have even answered some. If you have, thank you. The rest of the slide is pretty much shameless self-promotion, so I'll move right on. I did say we do forecasts. This slide is nice because it demonstrates the areas of the market we look at. We cover everything from software and servers through to services and networking. So we try to look at all aspects of the network. To a certain degree, that makes us a jack of all trades but master of none. This purple area here, if I can find the right button, is software. And it's a growing part of the market. It's becoming more important as computer systems become more complex. You can see here that we had a dip for the recession and had some comeback in 2010. That isn't quite enough to get us back on our original path, but pretty close. Unfortunately, though, we like to say that when you create a forecast, it has to be bound by what is realistic, whereas reality has no such limitations. You really can't predict for things like financial crises or floods in Thailand or whatever. So that this year we actually expect that the market's going to be down a little bit from what it would have been if Europe had been in a better shape, if the U.S. public sector spending had been a little bit stronger, and if Thailand had not had nearly half of the disk capacity of the world put in jeopardy. With that, we're still looking at growth of a little bit under 4%, and so that is good. A little bit of definitions. We track two parts of the market: high-performance technical computing or traditional computing. That's probably what most of you guys are in. Essentially scientific engineering computing, and with all the usual suspects for that marketplace, ranging from academia through to oil and gas and automotive and aerospace. And then there's high-performance business computing. This is an area that's more or less been trying to emerge since the middle of the last decade. And the applications in this area include trading on Wall Street, pricing analysis, risk analysis, and then run all the way through to very large ultra-scale internet facilities. The common point between these two is not the applications, but rather the requirements on their computer systems and how the computer systems often operate. This slide sort of breaks down those two markets into specific application areas, or major vertical markets is more accurate. One thing to note is that these markets are not actually the same size. This is not drawn to scale. The technical side of the business is about 70% and the commercial side is about 30%. So that this, this area here for financial analysis is about equivalent to this blue and red segment here, which is all of manufacturing. Another interesting point is that the traditional market is really divided between public and commercial sectors. So academia and government make up about 60%, and the other 40% is commercial. This is important in considering software because, as we'll see in the next slide, the software configurations can be very different between segments of the market. The commercial part is, or the business computing part is really 95+% commercial computing. Well, not exactly in the next slide. I'd like to go a little bit into software here and talk about some results from one of our studies, which is a budget distribution study. We asked end users to break up their budget into 5 or 6 major segments, and then later on to divide each one of those segments into someplace between 3 and 6 subcategories. These are just looking at the major segments. One of the more interesting trends is that hardware is going down as a percentage of the overall budget. And if you want to know where that goes, it's going into facilities. Power management, cooling is taking up a bigger piece of the budget, and this is becoming a real issue in the marketplace. Software, whoops, right here, it's been pretty stable in terms of overall budget spend at about 15% of the complete budget. To note that this budget also has staffing and facilities in it, so it will look different from some of the other slides we have that just look at product spending. One last point is that cloud and utility spending in the budget's been under 5% for each year we've tracked it. And more than 50% of that funding in the last year has gone to private clouds. This may indicate that we're talking to people who consider themselves cloud providers more than cloud users. And this may indicate the maturity of the market and the difficulty of really getting very specialized applications running over the cloud in a cost-effective manner. If we take a dive a little bit deeper, we can look at the budget distribution within within the software category. And here we see that middleware, this red band, has been pretty stable throughout the years. And system software is going down a little bit. That may be variability. That just may be that the systems are getting a bit more stable and less variable over time. What has been going up is 2 areas. One is this green area, which is software development tools. And the other is the one at top, which we call transfer costs. That's money you pay to someone else in your organization to develop software for you. And what we're really seeing is that as computers become more complex, and that is single thread performance is no longer being driven by Moore's law in favor of multiple threads at different levels, that people are really being forced to develop a lot more of their software, and their spending's going in that direction. I alluded earlier to a slide about the differences between software utilization in industries. If we look at some major application areas and divide them out by whether they're open source, public, which is basically a controlled form of open source, something like Gaussian where you actually have to get a license. But if you're a university, the price or the cost is nominal. And then in-house development and commercial ISV software. So we have 4 different looking organizations. The first one is BIO, which is almost entirely some form of open or public software in use, and a little bit of in-house and just a little bit of commercial. We can pretty much take CFD and structures together. That is a big piece of the commercial world. Aerospace, automotive, and they are heavily, heavily dependent upon third-party ISV software. Much as this is due is to ability to certify their codes. Some of it's due to very tight schedules for projects. An engineer gets 6 weeks to come up with the best result they can, and they want to get as much computing done in that 6 weeks because at the end they don't get another chance. Oil provides a third look at the market, which is something that's an area which is very much dependent upon in-house codes. Oil companies make money by searching for oil, and that is a competitive advantage. You can't get a competitive advantage if you're using the same software everyone else is. So they try to hire better geologists and programmers to come up with better ways to find that oil. I don't know how well this is visible, but if we break down, go one level deeper, and look at middleware share specifically, we see the subcategories that we talked about earlier for this area. And here, two-thirds of the market turns out to be software development stuff, compilers or compiler suites or language tools. To a certain degree, if you're going to give a scientist, an engineer, a computer, you have to allow them to write or her to write programs. But it also, to a certain degree, reflects the increasing importance of software in general. The two areas that we're most interested in for this talk are the job management in purple and the systems management in green. We'll also take a little look at the cloud and grid computing segments. Here you're going to get as close to raw data as we get. And this is number of mentions from a site census study. So we essentially ask people, what are your top 5 software packages for system management or for middleware? And they just list them out, and we go through and do our best to code them. We ask first, what is the package, what is it used for, and specifically what sub-function does it have. And then we use that to code this up. I've got to say coding is a little bit of a black art. And some packages may end up in areas that you don't agree with us in, and please send me an email, let me know. But what we find here is really turn and talk at the same time. Fortunately, I'm not chewing gum. That's about as funny as I get, by the way. After this, it's one long anticlimax. But it's interesting to note, first off, that when we asked for the deeper level of information, about a third of the respondents didn't tell us, didn't bother to tell us what that was, or thought that the general statement was enough. That job management really is only one thing, and you can call it job management or scheduling, but it is the largest single application or sub-function application that we have, and because of that size, we decided it deserved a given category. Cloud doesn't show up very much here, and that is really because there are lots of products that users said fall into one area that also fall into cloud. We took what we thought was the primary area of use and put them in that area. That a product for our work can only fall in one area. We cannot double count products. So that, for example, Grid Engine really shows up as a scheduler rather than a cloud product. Middleware Trends. A couple of slides here. Okay, we're coming down to the 10-minute mark, so we'll speed up a little bit here. We look at share by those specific areas we looked at before, cloud, job management, and system management, and see that job management has been picking up over time. We think that is a result of increased number of nodes on systems. Within those nodes, there's an increased number of CPUs. Within those CPUs, an increased number of cores. And within those cores, an increasing number of threads. Somehow, schedulers and job managers have to be able to do that and tend to that so that carefully parallel programs won't be sequentialized at the job management schedule level. And that's not even considering hybrid systems and hybrid processors. So it's just getting worse and worse. On the other hand, that's job security for most people in this room. System management's going down a little bit, but it's better integrated. And we think that as generally as products mature, the number of different products that gets mentioned decreases. And so it's an indication of maturing of the market. Same with cloud and grid. The bottom slide or chart, share of selected middleware by type, is a fun chart because it's so chaotic, really. And I think this sort of reflects the chaotic nature of the software market, where one day a product is public, another day it's private, another day a open version of that product comes out, and so you get a continuous shifting around of what's actually falling in what category at any given time. Moving on, and this is a deep dive into shares for the job management category, both in terms of the package mentions and the supplier mentions. As a single term, grid engine wins. But if you look at the sort of the larger constellation of Moab products, they come in at 23% for Moab. If you want to include torque, you get up to about 36%. This number sort of is also reflected in the positioning of adaptive computing as the top mentioned software vendor in the job management, or software supplier rather, in the job management area. It's interesting to sort of think about the difference between the 20% and maybe the 23 or 36% as the difference between licensed products from Moab and open supported products from Moab. But that's the sort of conjecture we get into over time. A few quick notes. Microsoft made a big push into this market in the middle of the decade, and so we're beginning to see them here. And they've really sort of backed off from that, gone to a cloud Azure strategy. And the last survey or so, we've really seen a reduction in the interest. It's sort of a case of a product succeeding, but not fast enough for a big company to go with it. Let's move on. System management packages and suppliers. This is interesting because, getting back to that slide with the different industries and the different distributions, system management is really an open source in-house sort of marketplace. Microsoft shows up a little bit. Arguably, some of the other suppliers that we have down here as not open source might be considered that. And that, it's just what do system programmers do but write system programs? And where is computer science putting in a lot of its effort right now? So we see a lot of specialized programming here. Last area, cloud and grid packaging. Not really a whole lot of dynamics here right now. A lot of open source. A lot of that is because there are a lot of just general distributed computing tools that are going to work over cloud. Cloud is another instantiation of distributed computing, which is wonderful because it's a really big instantiation when you consider the size of the internet. But, and it's good for the software people because everything you know is going to be applied elsewhere. And I'd like to just finish up with this slide here in defense of software. It mainly looks at the complaints about the cost of software at the application level, but I think really applies at all levels. Architectural change is making software making hardware much more complex. Middleware really exists to mediate between the complexity of the underlying platform and the end user. You can design an architecture of arbitrary complexity, but it's very hard to find a system programmer or application programmer of equal complexity over time. So you need a lot of software to make that difference, make the system usable. And that's all getting laid on the software developer's shoulders, and strangely enough, nobody thinks they should get paid for it. Regarding multi-core, users right now are largely deploying on single-core systems. Getting a stop sign there. Okay, 2. We're really seeing very small levels of parallelism. Once our last survey, we asked what the general size of a parallel job was in terms of nodes or processors, and it was median point was 36. It went up as high as 10,000, but it was a very long-tailed curve. In terms of scalability, sometimes you have to go all the way back to the model to get a scalable model before you can make it scale on an application. And to make things worse, there's always a battle with the software community just building their own after someone's invested a lot of money to put together a bulletproof product. So, in conclusion, the middleware market's looking pretty good. Moab is a major piece of it, and we should pay more attention and give a little bit more respect to the software guys. Thank you very much.